Oops. I'll tell you really quickly about the adventure of catching Ellie. Ellie is yay big, 45 pounds. So we were circling through all these neighborhoods in campus, which I know very well now because I've traveled it multiple times in the past 4 days. And I was getting ready to go home because I've been out since like till 10 o'clock on Friday night, and then got up at 6:30. Got out at 6:30 on Saturday morning. It was about afternoon. I was starving, and so I was like, I gotta go home and grab some lunch. Let my dog get some water. Big Wally, who's like Great Dane, he's pretty tall. Anyway, he was helping me. He was more of a distraction than anything. So he was like, "Can we pet your dog?" I'm like, "Yeah, we're gonna find my other dog with this dog, so we're gonna go." But I went around this last little place, and I looked down this ravine. And there's all leaves, and it was behind the elementary school, and they had like a big ravine and then a fenced-in backyard, and she was on the other side of the fence. So I saw her little white face and all these leaves, and I was like, "Ellie!" And then I like started crying a little bit. I was like, "Oh my God, I found Ellie!" And then Wally didn't know what was going on, and so then I had to cut my car off. I left everything in there, and I was like, "Okay, let me go get Wally because she might be scared of me, but she'll at least come to a fellow dog." So Wally pulls me down this huge hill. We get like briars and stuff all up, scratched all up. And I get down to the fence. I was like, "Oh gosh, what am I gonna do with Wally? I'm by myself. What am I gonna do with Wally? He's an idiot. Like he's gonna run away." So I tied him up to the fence. I jumped the fence. Yeah, jumped the fence. And get over. She like just licks me to death, knocks my glasses off, breaks my glasses. And then I was like, okay, she's 45 pounds. How do I get her back on the fence? I can't climb the fence and pull her with me. I didn't want to throw her because she was limping. I thought she broke her leg. And so I was like, okay. Well, in the meantime, Wally's super excited we found his sister. All legs. Has done 6 circles and wrapped himself up in the leash. Well, he's just like all legs together, and he's like, falls down, and he's laying on the ground like this, all legs together. And I was like, "You idiot! Like, how am I going to get you taken care of?" And Ellie. So then I was going to try to jump fence, and I was going to try to walk around, but I was scared Wally was going to freak out, so I was leaving him. And I walked all the way around the neighborhood back to the back of the school. So I had to call my friend. I was like, "Will you come help me? I'm holding my dog, but one of yours." Like flailing on the ground, and then so anyway, we got to the emergency vet, and she's home now. But she slept for like 2 days because I don't know that she slept in her like frightened kind of sense of the world for those couple of days. Anyway, so thanks guys for your positive thoughts. All right, so element versus compound versus atom versus subatomic particles. Let's start with our generic term, and then we'll kind of get into actually like the physical matter, okay? So give me an example of an element, anybody? Gold, right? So AU. All right, so copper, I don't know why I was just say copper. Gold. Gold is an example of an element. And the element of interest, every atom of that element has similar properties. So what do you think an example of a characteristic of this metal would be? A characteristic of this. Okay, it might be stable in terms of its reactivity. Actually, gold is pretty gold is stable enough, but it's somewhat reactive, and that's why we usually make alloys with gold, like gold and silver, because it's really malleable. Remember, like malleable and ductile, we talked about some of those characteristics of metals. So all atoms of gold have similar properties, or the same properties. And some of those things are going to just be related to their generic properties of metals. And you may have noted even some of those on the back of your periodic table. All right, so an element is just going to be describing a particular group of atoms. And they have properties associated with them. All right, what would a compound look like if I had to draw a picture of a compound? We looked at some of our particulate matter cards. Yeah, James. Maybe I'll say 2 atoms of elements together. Okay, so the atoms are the parts that we're describing, and they are of a specific element. So 2, maybe 3. I'll make this one a familiar one. H2O. So multiple atoms equal a compound, and those atoms can all be the same, or they can all be different elements. So in this one, I've got different elements. I could also make some that are like 2 oxygen atoms, like this and this. Oxygen, oxygen would be O2, and that would be an example of a compound, but it's the same element. Okay, so then an atom, what's like the technical definition of an atom? give me the best you got here. Evan, what you got? Best definition of an atom.
Smallest part.
Smallest part of matter. Okay, or like maybe not divisible anymore. And there's the point that we can divide an atom even smaller because we know there are subatomic particles, but it's very difficult to. We do know that there are things that make up atoms. So, smallest part of matter. Okay, and so then even smaller than the atom, we've got 3 subatomic particles. I know you probably looked up a list and you saw quarks and you saw all these other things online, but we're narrowing it down to 3. What are they? Protons, neutrons, and electrons. So I like to denote them like this because it gives us more information about them. So what is this positive, or what is this plus thing doing up here? Okay, so you're saying it's a positive charge. What is this 0 up here? Neutral, no charge. And the negative, negatively charged. And each of these subatomic particles make up different parts of the atom. So what are the 2 main parts of an atom? What's the middle called? The nucleus. Which 2 subatomic particles exist in the nucleus? Right, the neutrons and protons. They exist in the nucleus. This is not like the nucleus of a cell. The nucleus of a cell is made up of a bajillion atoms. The nucleus of a cell is much, much, much bigger than the nucleus of an atom. And so those are made up of a couple of protons and neutrons depending on the identity of the element. And then these exist in their own little special place called the, guess what, electron cloud. It's pretty evident what is present there. And that's, this is just, not recently, but this has been discovered in the past 100 years. Look at my timeline again. But before that, we just thought everything was like a blob. We didn't know about the subatomic particles. So there's this evolution of the atom. What does evolution mean in that sense? Not evolution of species, evolution of the atom. Say again? So there's been the discovery of, evolution doesn't necessarily mean complexities, but it actually does resemble it in this case. Evolution just means change over time, right? Simple to the point. Evolution means change over time. So the model of our atom, the way we depicted our atom, has changed over time. We used to say it was a blob. Now we actually are to the point where we say it looks like orbits. We've got all these electron clouds. We know a lot more detail about what's happening in the atom. At least we have theories and evidence that supports it. So there are these 7 scientists that were involved in the evolution of the atom. Okay, they all have different colored faces. I do not want to draw them. So what you guys are going to do today is you're going to look into some more detail about what did each of them contribute to the model of the atom. Whose is most recent, meaning our modern model, modern meaning current, and which is the most historical model. And you're going to kind of give some details about who discovered what part of the atom, how they discovered it, meaning their experiments, and then whose information they used beforehand, okay? So you guys are going to take notes on this. I have like little pictures for you so you don't have to draw everything. And then on the back, there's more space if you need it. So usually once every other unit, I'll do self-guided notes because some of it is not as exciting for me to talk about, and you listen to me yab about it. So you can probably get what you need to from my notes. And after that, you guys are going to start a historical model project. The multiple choice from this class, I'm about halfway through free response. The multiple choice from this class was very good. There were some that I'm going to give you guys. I have 2 I'll probably give you guys back points on. But because we have a couple people missing from the test, I'm not going to give that back to you just yet, okay? So I'll probably assign anybody who needs extra help some teal later on this week. But instead of me boring you to tears about the evolution of the atom, you guys are going to become a scientist, and then you're going to actually portray yourself either through some form of social media, okay? You can portray yourself that way. You can make like a t-shirt about yourself. You can make a biography box about yourself, whatever you need to do, but it needs to be something physical. So if you make make a Twitter account about yourself as a scientist, you need to print out like your tweets and stuff like that, and you'll be presenting this to the class in groups next week. Not this week, later next week, okay? So let me show you where this stuff is on my website. Before I show you that though, let's get Chromebooks going. Okay, so if you are Chromebook 1 through 10, go grab. and go to my website. If they're on the wall, yep. So give me, you're probably like 15. Just give me a second. Okay, if your Chromebook's 11 to 20, on the day, you grab what you need. Your Chromebook specifically. Oh, and pass out these little papers while we're going here. So before you get started, so I'm basically having you guys just pull up the Chromebooks and go to my website first, and then I'll let you know where to start the notes. So remember, if you have a partner who's absent, make sure you grab a paper for them and their name. Okay, so before we actually jump into this, I want you guys to form groups, but I gotta tell you how big your group should be, because these are the groups you'll be sharing your science information in versus. Okay, so I need 3 groups of 7. Oh, sorry, if you don't have your Chromebook, go grab your Chromebook. Yeah, start going. I need 3 groups of 7 and 1 group of 6. What I can do is everybody who's absent will be in the same group, and that way they can all get started on it together when we get to the group. Just pull my desk. Okay, so I need groups of 7 and 1 group of 6. Can you guys organize yourselves in less than a minute? Yeah. After you get your Chromebook pulled up? Okay, I need you to like literally get up and clump. So I'm using a group. Okay, and while you're getting in those groups, decide which scientist you are. You need to each assign yourselves to scientists. They're on the board. Decide yourselves on to be a scientist. No, not Goldstein. Goldstein's not on the list. Look at the list up here. Okay, who's my group of 7? Raise your hand. Do I have a group of 7? Is everybody 6s? I gotta have 7s, people. Is this a 7 or 6? 6. Okay, I'm starting with 3. So, all right, you guys got 7. Hold on. We have 7. Now you have 7. Take it. You guys are 7. Okay, what are you guys in the back? Matt? You are 6. Okay, and you guys are just. Is it just you right now? Okay, you were getting the rest of the process. So you guys have to pick of the pot of who you want to be. Okay, so you guys are gonna get everybody else. You don't need them right now. They just need to know who they are. Okay. All right. So actually, what I'm gonna do is, you remember who's in your group. Make it. Remember who's in your group. Like snapshot. Okay. You know who's in your group. Take a selfie. I don't care. Okay. And then go back to your seat so I can explain the rest of it. You just need to know. I need another sheet. All right. You need now in your groups. Did you assign who was who? Okay. Take 30 seconds and assign who's who. Milliken, JJ, Chadwick, Rutherford, Dalton, Bourne, Schrodinger.
I got it. I called gold. I got it. No, I called it right. What do I have? All
right, you're 10 seconds. Write down who you are. All right, everybody has an identity. This is your alternate personality now, okay? You are going to become them next week sometime. I'll tell you the due date. Okay. You know who you are. Shake your head for something, people. Okay, I do have a little list. I need to know who you are, so I'll come around while you guys are doing your notes and write down who you are in that individual group. Okie dokie? So, when you get to my website, go to Unit 2 Documents. Find it. Unit 2 Docs, and it says Historical Model sorry, I lied to you. It says Chem Atomic Model Notes Student. Chem Atomic Model Notes Student. I'm very specific. And there's a PDF, and it will follow your guided notes pretty well. There are a couple extra slides with some more information. So this is the minimum you should take. If there are extra things, don't write it word for word, summarize it, and write down a couple of extra things. Because what you're going to do is this is your brief background of every person. And then afterwards, you're going to start researching more information about you, the scientist that you've selected, and I'll tell you where to find the rubric online too, what you're going to specifically be looking for. So this is so you're going to the Atomic Model Notes student under Unit 2. You might have to hit more on the first website you get to. But when you click here, it's going to pull up document like this. So at the very top it says beginning with the atom, and then it says Dalton's atomic theory, and you can summarize these. Please do not write word for word. After you get finished with that, that's when you'll delve into your personal details based on the scientists you've selected. And here's what I need from you. Go back to my website and go where it says historical model of the atom project social media theme. Got it? PDF. This is for your individual scientists you've selected. And I've got the PDF pulled up right here. So you're going to be sharing about yourself in more detail with those 6 to 7 people, and that's going to give us kind of the most detail about that scientist. So the beginning part is going to take you maybe 30 minutes to go through initial. So these are your people, and then you're going to act like your scientist on the day, D-Day, whenever I say it is, and your specific scientific contributions to the evolution of the atomic model. What I need from you, and this can be just bulleted information, so if you just want to copy the questions and underneath just bullet some information, it does not have to be like a narrative, it does not need to be like an MLA paper, anything like that. I do want you to cite your sources, but not like formatting and information like that. So who you are, interesting facts, your model, your experimental use, your results, and some of this is in my notes, but you might need to dig into some more detail on other sites. This is kind of like the information research component. So the one that people don't know is predecessor. That means the person who came before you that kind of did something and you piggybacked off of their information and you went further. Okay. So after you get kind of into that, there's some. I don't care if you cite MLA or APA. Later on, when we do our honors project, we will be using APA. So if you want to look into that, that's fine. Now, this is just a preview. After that, your model, your product part of this is going to be whatever you choose. You can choose either making a 3D model, box biography, which is like a shoebox. You can put stuff in it to talk about yourself when you're sharing with your crew. Instagram profile, tweet timeline, magazine, website, column. A lot of people did websites last year. It was really good. Wix, or what's another website maker? Google website. There's one more. Weebly. There's lots of websites out there. You can make Pinterest account, my fave. There's some examples of what I might be looking for. Darwin with his selfie. Okay. So those are my basic products. There's some examples underneath each of these, and yours will be, yours will look different, but make sure you follow the rubric embedded in each. Or I'm including in other categories. Like if you find something that you're like, hey, I really want to do this, let me know and make up your own rubric, and I'll approve it and add to it if I need to, or take away bullet points if I don't. Okay? So you're taking personal notes first, and you're researching your person. And then you're going to decide on a product soon. This is not due for a while, but do start on it, okay? So tonight's homework is to work on your research and start PS4. I'm not taking it tomorrow. I just want to see if you have any questions for her, okay? All right, get on it. There's no video to my notes. It's just handwritten stuff. So do what you got to do. If you need to spread out, spread out. I understand personal space is an issue. If you want to talk to people as you're going to say, like, how would you summarize this, that's fine.